Now let's look at problem 3. So this is looking at all sorts of different things involving calculations of exponential growth. So for 3A, we have a bank account that starts out $1,000 and gets 4% interest. So I'm going to write the equation right away. That's 1,000 times 1 plus the rate of change, 1.04 to the t, and it asks how long to $1,500. So I know I'm going to need to use logs. So I've got a how long problem in an exponential situation. I'm going to set that equal to 1,500. I'm going to solve for this bit by dividing both sides by 1,000. So I'm looking at 1.04 to the t is equal to 1.5. Now that I have that t up in the exponent, I pull out the log. The log of 1.04 to the t is equal to the log of 1.5. The whole reason to do that is to get that t down out front. T times the log of 1.04 is equal to the log of 1.5. T is equal to log of 1.5 divided by log of 1.04. And now I just go to my calculator to figure out what that is. And I plug that in and I get 10.3. What are my units? Years. What am I doing here? So in 10.3 years, I should have reached $1,500. And again, you probably ought to check your work by taking that and plugging it in over here and seeing that you get the correct answer. The second problem is a little more complicated, except it doesn't ask you to solve for t, because you start out with $2,000, you get 4% interest for 5 years, and 6% interest after that. And it asks how much you're going to get 20 years from now. So I'm going to start with what would happen for the first 5 years. For the first 5 years, we get 2,000 times 1.04 to the t, as long as t is less than 5. And so let me just calculate what that is at 5 years. I would get, by plugging 5 into this, $2,433. And now I'm going to look at this second equation, the second situation, where I'm starting out, this should feel a lot like piecewise linear functions. I'm starting out with $2,433. It's growing by 6%. And I actually have a choice here. I can just say raised to the t, where t is the years after year 5. Or I could have said raised to the power t minus 5, where t is years from the start. And I could really pick one or the other. This wasn't really asking you to write the equation, just to do a calculation, so I can pick one. In either way, I am going to be raising this to the power 15, because I have 15 years of 6% interest. So this happens for 15 years, and it doesn't really matter how you write the equation as long as that is what you are calculating. And so after 15 years, I would have 2,433 times 1.06 raised to the 15th power after 15 years of being in this situation, 20 years from the beginning. And that works out to 5,800, and it rounds to $31. So after 20 years total, 5 at 4% and 15 at 6%. Okay, next I'm going to go grab another sheet of paper to look at the next two parts of this problem. So for problem 3C and D and E, we're looking at cities and populations. In 3C, we have a city whose population was 52,000 in the year 2000 and 55,000 in the year 2001, and grows by the same percentage or grows exponentially. We're asked to find its population in 2010, but before I even think about that, I want to think about, what do I know? I have a starting amount here, and I need to find the percentage change. So what is that percentage change? It would be, well, we know how to do this, new over old minus 1, 55,000 over 52,000 minus 1, and that gives me a percentage change of 5.8%, 0.058. So the equation for this city would be starting amount of 52,000 times 1 plus the rate of change. Yes, I subtracted the 1 here and I'm adding it right back on to the t, where t is years since 2000. So in 2010, t would be equal to 10. That would be 10 years after 2000. So it would be looking at 52,000 times 1.058 to the 10th power. And that comes out to 91,400 people. Part B, I'm looking at another city which starts out with 7,000 people and is shrinking by 3% every year. So that tells me it's exponential. So its equation will be 7,000 times 1 minus 0.03 to the t, or 7,000 times 0.97 to the t. And then E asked us if this city in part D will ever be smaller than the city in part C. And certainly it will, because its population is shrinking. And let me graph the two of these. The city in part C looks like this. The city in part D, oops, that's not supposed to touch 0, looks like that. So I need to set them equal in order to find that crossover point. So I'm looking at the equation, 52,000 times 1.058 to the t is equal to 70,000 times 0.97 to the t. And okay, what am I going to do? I'm going to get the numbers to one side, the to the tth power to the other side, and then I'm going to hack my way through the algebra. So divide both sides by 52,000. I know I'm going to need to use logs because I've got t's up in the exponent. So I'm going to divide both sides by the 52,000 to get rid of that. I'm going to divide both sides by the 0.97 to the t to clear out that. And I am looking at 1.058 to the t over 0.97 to the t is equal to what I get when I punch those two into my calculator, which is 1.35. So that's the equation that I need to solve. Now I use this algebra trick that we talked about in class to simplify this left-hand side. The left-hand side becomes 1.058 over 0.97 to the t is equal to 1.35. And now I'm going to have to do some algebra, and I'm running out of space a little bit. So I will grab a new sheet of paper. Sorry, this might get a little bit messy. 1.058 over 0.997 to the t is equal to 1.35. Pull out the logs, take the log of both sides. The log of 1.058 over 0.97 to the t, yay, nested parentheses, is the log of 1.35. T times the log of this whole mess, 1.058 over 0.97 is equal to the log of 1.35. T is equal to, this is ugly to write down, but it's just some numbers that you can punch into your calculator. The log of 1.058 over 0.97. And I better get an answer which is positive. If I got a negative answer, that would be a big screaming warning sign, and it should take a few years. So if you plug this all in, you will get T is equal to 3.46. You could round to 3.5 years. So after 3.5 years, 3.46 years, the two cities would be the same size. I suggest that you plug this in and check into the original equation. Plug it into this equation here and this equation here and see that you get the same thing. Before then, city D is bigger. And after that, the city in part C is bigger. So there you go. That's problem 3.